We are on the second video for section 19.2, and there are only 2 more examples on this, so it'll be a fairly short video. You discover a savings account belonging to your great-grandmother. It has been earning 1 3/4% annually for 48 years. The balance is $36,317. How much money did your great-grandmother originally put in the account to the nearest dollar? Okay. This is one of those ones I find interesting, which it would be real nice, wouldn't it, to find an account that had $36,317. I would be okay with that. So that is the future value. And we want to see, what did she put in this account originally back 48 years ago? And it's annually, so it's just 48 periods because it compounded, the interest compounded annually. Now, the thing that you find out about interest is it's all about the time. The time really makes a difference. So 48 years is a long time, even though this interest rate is pretty small, right? 1.75% annually. So we just divide by 1, which means we leave it at 1.75%. We are going to compute the present value. And now it might be fun just to think about, I wonder how much this was. How much do you think it was before you actually compute it? Because I think you'll be surprised. And it's because of the 48 years. When you compute this, you get $489.03. Now it said to the nearest dollar, so we're going to say she deposited $489 48 years ago, and here's how it grew. And lucky you got the account. I guess that's kind of one of those things that we wish would happen, but probably it doesn't. Here's our next example. This is one of those ones similar to the one about the Jeep, where we were trying to see if there was enough money. Earl, owner of Papagino's franchise, wants to buy a new delivery truck in 6 years. He estimates the truck will cost $32,000. If Earl invests $21,000 now at 5% interest compounded semi-annually, will Earl have enough money to buy his delivery truck at the end of 6 years? So I'm going to compute the future value first. It's 6 years compounded semi-annually. He can invest $21,000. So that means he will put $21,000 in an account and not pay any payments. And then of course we're going to compute the future value. It's compounded semi-annually for 6 years. So we take 6 times 2. We will have 12 periods, and then the interest rate is 5. We're going to divide that by 2, so it will be 2.5% monthly. Remember, we don't put the percent in. Our calculator knows what we're talking about. And then we're going to compute the future value. So go ahead and compute your future value and see what happens there. And you'll see that future value is $28,242.67, and so he needs $32,000. So you can see that he does not have enough, right? Less than $32,000. And then we're going. My pug is snoring real loud, but you may not hear it. I have my headphones on. He just makes me laugh sometimes. So it's less than $32,000. We're going to verify this by calculating this a second time based on the future value, and we're going to find present value. So let's put in 32,000 here. Let's see what happens. Our payment stays the same, our interest rate and the number of periods all stay the same, and then we compute future value. So the future value that present value, we're going to compute present value and see how much money would need to be deposited to end up with the $32,000. Sometimes I just get a little tongue-tied. All right, so when you compute the present value, you find that he would need $23,793.79. So he's a little short because this is more, right? It's more than $21,000, which is what he currently has. Okay, so if he's going to invest $21,000, you can see that that's not enough. And the answer to the question then would be no, he's not going to have enough money to buy the delivery truck. He's going to be short by close to $4,000, and you can see that from the first calculation. Or he would need to invest an extra $2,793 if he could put more money in. All right, so we're finished with this lesson.